Hello, welcome to Revelator John. How does an aeroplane fly? Well, this is a very simplified view, but essentially an aeroplane has to be propelled through the air in order for it to fly. So air has to flow over the wing or wings in order for it to fly. So we have, imagine if you will, an aeroplane sat on a runway, and it can either be propelled through the air along the runway first of all, and then climb up into the air by the use of an engine-driven propeller, in this case of a single-engine aeroplane, which will generate rotor thrust pointing forwards, which will essentially pull the aircraft forwards. If we have big airliners, then we have jet engines strapped to the wings, underneath of the wings, and they will push the aircraft forward. So that rotor thrust is generated. When rotor thrust is generated, then air flows over the wing until such time that enough lift is generated over the wing that overcomes the weight of the whole aircraft. And then if we want to keep on climbing, then we just we'll go faster, or the aircraft will go faster and faster and faster until more and more lift is produced, and then we will vertically climb. So the greater the differential between lift produced by the wing and the static, if you like, the constant weight of the aircraft, then the greater the rate of climb, the greater the lifting potential, the climbing potential of that aircraft. So as the aircraft is rolling down the runway, it's being propelled forward by engine thrust or propeller thrust, it reaches a certain point where the airflow over the wings is enough to create sufficient lift to overcome the weight of the aircraft, and therefore the aircraft will start to climb. Now, the thrust may be manipulated, may be increased or decreased depending on what flight configuration they want, the pilot wants. So if they want to climb, they will generate a lot of power, a lot of thrust, engine thrust or propeller thrust, to create that pulling or pushing force, if you will, that rotor thrust, that engine thrust or that propeller thrust, that will propel the aircraft forward and generate an increased airflow over the wings itself, which increases the lift. Once in straight and level flight at cruising altitude, then the engine thrust or the propeller thrust may be reduced, retarded somewhat, so that they can just maintain level flight. So the wings generate the lift, the engines or propeller generate the thrust. The weight of the aircraft we'll say remains constant. However, obviously we would have to factor in for fuel burn, so there is a decrease in weight as the flight progresses. So how does the airplane turn? Well, the aeroplane is turned by extra wings, if you like, which are attached to the large wings, and these are smaller wings which are called ailerons, and they operate slightly differently to the wings itself, in that the ailerons can move, that we can change their pitch slightly. And the effect of the ailerons is that they'll decrease or extend the airflow over the wings themselves. So if the airplane wants to turn to the right, then one aileron is changed one way, and the other aileron on the opposite wing is changed in the opposite direction. So therefore you'll have a loss of lift on one wing, increase in lift on the other wing, so therefore the aircraft will want to bank over, and the opposite is true to the other side as well. So those are the ailerons which make the aircraft turn. The wings generate the lifting force to overcome the weight of the aircraft. Ailerons will make the aircraft turn. So then we have also the flaps. So the flaps again are similar to ailerons, but they're not used to generate a turning force on the aircraft. They're used to generate greater lift, in other words, to increase the size of the wing so that more lift is generated at slower speed. So the use of flaps for coming into land, for example, where they would have more lift coming in at slower speed. So we want slower speeds for landing because obviously that will be the safe landing speed, if you will, of that particular aircraft, and also it will be more controllable once the aeroplane wheels, for example, or the skis or the pontoons or whichever, when they actually make contact with the surface. And the flaps work essentially again by there are various designs, but that you can have the wing, and at the tail, the rear section of the wing, you can have flaps that actually can extend out, and they will increase the surface area of the wing itself, thus increasing the airflow distance, thus increasing the lift of the wings themselves. Now, we also have at the rear section of the aeroplane what is known as the elevator. So the elevator is another mini wing, a small wing, either side of the vertical tail fin at the rear of the aircraft, which is another lifting surface, and that elevator can be moved up or down, or to act very similar to the main wings, and that will generate lift vertically up or down. So when the aircraft is flying forwards, they have the two wings here, and they're generating the lift. And then to control the attitude of the plane, the aeroplane, the pitch of the plane, the lift generated by the elevator at the rear will actually increase or decrease the pitch of the aircraft itself. So those are the main controls on the main surfaces on the aeroplane that cause it to fly. So we'll have the engines and the propeller, which will actually generate the rotor thrust to propel the aircraft forward. We'll have the wings that generate the lift. The ailerons will generate increases in lift and decreases in lift over the wings to create an uneven lift differential over the whole wingspan, which will create a turning force left or right. We'll have flaps that increase the surface area of the wings, and those are used primarily for landing, so the aircraft can be landed at slower speeds. And then we have the elevator at the rear of the aeroplane itself, which is another lifting surface generated to generating lift, which will add to or control the attitude or the pitch of the aircraft in flight. Now, one thing to notice here, I often refer to as the aircraft having to move through, having to be propelled through air. Now, whilst in, let's say, 95–99% of cases that's absolutely true, the aircraft has to be propelled forward in order for it to fly. With very small instances and with small single-engine aircraft, it is possible for an aeroplane to fly with a very strong wind, so that if a very strong wind is flying over the wings itself, the wind itself will create an airflow, which will create a lifting force, and that will lift up the aircraft itself. That's why it's really important to tie your aircraft down if you're not flying it, but also the potential is that an aircraft can be landed on a runway with minimal engine power, with minimal flaps, because the wind is acting on the lifting surface and generating more lift than would normally be done as well. We also have to consider other aircraft designs such as vertical takeoff aircraft. Now, I'm not talking about helicopters, I'm more talking about the JSF fighter, or the, as previous, you would say the Harrier jump jet, where nozzles of air, if you will, jets of air, are directed downwards to create this vertical propulsion, and then the jets they change direction, so that creates the forward motion, the forward propulsion. But in conventional aeroplanes, we'll have the engine thrust, or the propeller thrust, we'll have the wings, the ailerons, the flaps, and the elevator, which create the controlling effects on how that's how the aeroplane flies. Thank you.